1066 campers bike 2. So for this problem, we are giving workers array and bikes array. It is similar to campers bikes 1, but the different part is for the return. So we're going to return the minimum possible sum of Manhattan distance between each worker and their assigned bike. Yeah. So for example, so for workers 0, definitely it's going to choose bike 0, and workers 1 going to choose bike 1. Because only in this case, the distance is going to be 3 plus 3, which is going to be 6. Yeah. Because definitely we want to return the shortest distance. Yeah. So it's going to be 6. Otherwise, it's going to be longer. So for example, if workers 0 choose bike 1 and workers 1 choose bike 0, definitely it's going to be longer for the Manhattan distance. Yeah. And this is the definition for the Manhattan distance. And yeah, and the length of the bikes array is longer than the length of the workers array. And there's going to be a brute force idea. Let's just try to check the brute force idea. So yeah, so this is going to be the brute force idea. We just permutate all the bikes array, and then we're going to compare them by one. So this is going to be a brute force. Yeah, but the complexity, time complexity, is going to be here. So for in permutations of bikes, yeah, so this is going to be 10 times 10 factorial. Yeah, and then here is another for loop. So this for loop is going to be another 10. Yeah, so this is going to be the time complexity. It means 100 times factorial of 10. Yeah, let's just check. What is going to be the value? Yeah, it's going to be slow because yeah, it is a brute force. Definitely it didn't work. Yeah, as you can see, this value is going to be like for zeros, it seems it is 3 times 10 to the power of 8. Yeah, for 3 times 10 to the power of 8, definitely it didn't work. Yeah, so this is why the brute force didn't work. We have to try to figure out another way to solve the problem. Yeah, so let's just try. Let me just submit it. Yeah, we're going to wait for some time, and then it's going to be time limit exceeded. Yeah, as you can see, it is time limit exceeded because yeah, because for the time complexity, it's nearly to 10 to the power of 8. Yeah, normally it didn't work. So we're going to use another way. So another idea is that we're going to use the DP to solve the problem. Yeah, so dynamic programming. But we're going to use bit mask DP. Also, we call it bit DP. Yeah. So for each of the bikes, so how many bikes do we have? So yeah, for each of the worker, so we're gonna have the workers from 0 to n minus 1. Yeah. So we're gonna have n workers and n bikes. Yeah. So for each of the worker, definitely this worker is gonna choose a bike. But currently I don't know. For example, this is 0. I don't know which bike I'm gonna choose if I have the shortest distance. So the normal idea is that I'm gonna use the brute force to solve it. Yeah. But what if we store all the previous calculated value, and then we're gonna use the previous calculated value? So this is the dynamic programming idea. Yeah. So we're gonna use a bit mask. So from the beginning, we're gonna prepare the length of the bikes array. For all the bits, we're gonna prepare it as 0. Yeah. So this is the bikes array, and we're gonna use the bit mask to represent it. So from the beginning, everything is 0. So if this bike, so for example, this is the index 0, 1, 2, 3. So if this bike is chosen, so I'm gonna set it as 1. Yeah. So let me just use another color. So I'm gonna set it as 1. So if this bike is chosen, I'm gonna set it as 1. If this bike is chosen, I'm gonna set it as 1. Yeah. So next time, while I'm checking this bike, oh, because it is chosen, so it means I cannot choose it. I have to choose the next. Yeah. So while I'm choosing all the bikes, so if the bikes equal to n, yeah, for the workers array, so for the workers array, if the worker equals to n, definitely the worker is going to be 0 to n minus 1. If the workers workers index equal to n, definitely it means I've already chosen all of them, so I'm gonna return a 0. Otherwise, I'm gonna check all the distance. If I choose a 1, I'm gonna check the distance, for example, for this worker, and for the next, I'm gonna choose another distance and then choose another distance. Yeah. So this is the basic idea. Yeah. Now let's try to use this idea to solve the problem. Yeah. So let me first define a function, distance array. So it's gonna have two variables, and I'm gonna return the absolute value. So let me just use this line of code. Yeah. So this is the distance array. X and Y are two places for the workers and the bikes. Yeah. So it's gonna be X 0 minus y0 and absolute of x1 minus y1. Yeah. So this is going to be the calculation of the distance. Yeah. Now let's just try to define the bit mask. So I'm going to define a DFS function. So inside it's going to be I. It means the index of the workers. And mask. Yeah. Let me give a path first, and I will to call the DFS. So it's going to be from 0, and the mask is my initial state. I'm going to set it as 0. If some position is chosen by a 1, so for example, at the beginning my state is always 0. So if this one is chosen, so I'm going to set it as 1. Yeah, as this is a bit mask DP, bit mask problem, and bit DP problem, we're going to use a case. So let's just use a case. Yeah. So the condition is that I'm going to check this I. If I equals to n, I'm going to return a 0. And let me just define two variables with n and m. So n going to be length of the workers, and m going to be length of the bikes, because m going to be more than or equal to n. Yeah. So this is the definition for n and m. So if if all the workers have been chosen, this means if I equal to n, definitely I'm going to return a 0. Then I'm going to set a result. I'm going to check all the all the different cases. So currently this I equal to 0 from the beginning. It means this is a worker. Now I'm going to choose all the possible bikes. So for J in range, I'm gonna have m bikes, right? M, yeah. So I'm gonna have a check if mask, or I'm gonna use an or operator. One left shift to J places. Yeah. So from the beginning, the mask is 0. If this becomes 0, yeah. So this means currently at this bit shifted to left with J positions. If this is 1 and the mask is 0, so I'm gonna set the mask. Yeah. If it is equal to 0, it means at that bit inside the mask it didn't use. So now I'm gonna use this bit. So how can I use it? Yeah. So I'm gonna update the result. Gonna be the minimum of the result with this one. So how can I choose this one? Actually, it's gonna be DFS I plus 1, and then I'm gonna use the mask. Yeah. So it's gonna be mask. It's gonna be mask and this value. Yeah, let me think about it. Yeah, this is add, not or. So if mask add this one is 0, because this is a 1, this means the mask is 0. So now I want to set the mask. So here I'm gonna use or. Yeah. So we must be familiar with the bit manipulation and the bit operation. So normally I would prefer to write it like this way. I'm gonna set the state as 0 from the beginning. I'm not set always to be 1. Yeah, because that one gonna be another writing of a bit mask. So I prefer to write it as a 0 from the beginning, and then here I'm going to use add, and here I'm going to use the bit or operation. Yeah, so this means I need to choose this one. If I were to choose one, definitely I need a distance. So the distance is going to be I to j. Yeah, and finally I need to return the result. Yeah, now let me just run it to check. Int object is not subscribable, subscriptable. Yeah, so the int object is not subscriptable. It means I cannot choose that. Let me, because currently this is just the index. I need to choose the value. So let me just choose the value. Yeah, so it's gonna be workers. And this one gonna be the workers, and this one gonna be the bikes. Yeah. So now let's just try to use the workers. So for the workers, it's gonna be the index. So x is the index. Yeah. So it means I'm gonna choose x. And for the bikes, I'm gonna choose y, and for the workers, I'm gonna choose x, and for the bikes, I'm gonna choose y. Yeah. Now what are we gonna do? Yeah, because here is inside the workers is x, but I need to choose the coordinates. So this is just the coordinates of x and y. I need to choose x, so this means here gonna be a 0, and here gonna be 0, and here gonna be 1. And here gonna be 1. Yeah. Now let me just run it. It didn't work. Yeah, but let me just print out the workers 0 or workers 1 to have a basic setting. Workers maybe x, and bikes y. Yeah. Yeah, at least I have some distance, as we can see. So here the workers x with 2, 1, and 3, 3, 2, 1 with 1, 2, 0, 0 with 1, 2, 0, 0 with 3, 3. Yeah, so this means the distance calculations would be okay. Yeah, so let me just delete here. Now I think the problem is about the final result. So the distance of I and j. Yeah, but before that, let me just print out the distance. Maybe I can get at least one distance. Why my final result is just 0? I don't believe it. So let me just print out the distance. Yeah, at least I can get some distance, and I really want to get the lowest distance. Yeah, because my result is setting as a 0, so definitely I choose the minimum value. It's going to be a 0, so I need to set the result to be positive infinity. Now let me just check that. Now as you can see, it works. Now let me just delete the print part and submit it to check if it works. Yeah, I hope this time it may pass for all testing cases, because definitely currently we are using the dynamic programming. We are using the bait DP to solve the problem, and the time complexity is this this mask. It is 10 times 10, it is 100, and for this for loop it is another 10. So the time complexity is 10 to the power of 3. Yeah, I don't know why, but let's just wait for a few seconds to check if it works. Otherwise, I have to. Yeah, now as you can see, it works. Actually, it is quite fast. Yeah, maybe at that moment it's because of the networking problem, but actually it is really fast because the time complexity is only 10 to the power of 3. This is 10, the mask is also 10, and here another for loop is also 10. Yeah, so this is why it works. I think this is a really good problem for practicing the BitDP problem. Thank you for watching, see you next time.